Hello everybody, welcome to this session of statistics, and today we will learn about the cumulative frequency and its representation in a graph. The graphical representation of a cumulative frequency gives us an ogive. Ogive are of two types, the less than type and the more than type. Today we will specifically learn about the less than type. Now before I tell you why the name less than type, let's start with an example. So I have an example of daily income of some of the workers in terms of Indian rupees. Now this particular data is a group data because it is divided into small groups. Every group is having a class size of 20. So there is a difference of 20 rupees. So 100 to 120, 120 to 140, 140 to 160, 160 to 180 and 180 to 200. And this particular income group also shows us the number of workers that fall in the corresponding category. So the column number of workers is nothing but the frequency column denoted as F. Frequency is nothing but the rate at which something occurs. That means 12 number of workers have a daily income of 100 to 120 rupees, 14 number of workers have a daily income of 120 to 140 rupees, and so on. Now let us start by calculating the total of the frequency. So the total frequency is denoted as sigma F. So 12 plus 14 plus 8 plus 6 plus 10 will give us 50. So this tells us that this is the frequency distribution. Now, a frequency distribution can be easily converted into a cumulative frequency distribution. Cumulative frequency is nothing but the running frequency. That means we have to add frequencies at every single stage. So let's form a column for cumulative frequency. Cumulative frequency is also denoted as CF. Now before we calculate the cumulative frequencies, let's come back to the point why the name less than type. Because in this case we have to actually take the upper limits. Whenever we say less than something, that means that something has to be of the higher value. So we are going to say lesser than 120, lesser than 140, lesser than 160, 180 and 200. So now let's form a column for all these upper limits. So 120 is the upper limit for the first group, 140 is the upper limit for the second, 160 for third, 180 for fourth and 200 for fifth. Now let's start with the cumulative frequency. We know that the frequency till 120 is 12. So the cumulative frequency for the first group is 12. Now if we want to calculate the cumulative frequency till 140, so we will add the frequencies from 100 to 140. That means frequency of the first group and frequency of the second group. So 12 will be added with 14, which will give us 26. Now similarly, the cumulative frequency till 160 would be everything from 100 to 160. So 12 plus 14 plus 8 will be added. So 26 plus 8 will give us the cumulative frequency till 160, which is 34. Similarly, we'll do for all the groups. Now if you notice, the last running frequency actually matches the total frequency. After forming the columns for the upper limits and the cumulative frequency, we will represent it in a graph. Now, upper limits will be actually represented in the x-axis because it is an independent variable, whereas cumulative frequencies is a dependent variable, so it will be located on the y-axis. Now let's plot all these points in the graph. Okay, so we have this graph ready with us and we need to form the x-axis and the y-axis. Now on x-axis we can see that there is daily income category, and on the y-axis, which is the vertical axis, is the cumulative frequency. Now before we start drawing a graph, we shall set the scales on the x-axis and the y-axis. Now for me, I have set a scale on the x-axis as 1 centimeter equal to 5 rupees. So we shall write scales first. X-axis is 1 centimeter equal to 5 rupees and y-axis 1 centimeter is equal to 2.5 units. Now in our x-axis, if we notice, there is a small discontinuity because we have started the graph right from the 100. So because there is a difference of 10 rupees between every daily income group, but there is a difference of 100 rupees from 0 to 100. So we put a discontinuity here. Now the first point in our graph was 120 and 12. So we will plot 120 from the x-axis and 12 is something here on the y-axis, which is this point. So this is the x coordinate and this is the y coordinate. The second point was 140 and 26. 140 is here and 26 is somewhere here. Third point is 160 and 34, which falls here. After we plot the points, we have to form a smooth freehand graph. Now this is an increasing curve which is characteristic of a less than type ogive. Now this is the graphical representation of a cumulative frequency distribution. From the same graph, we can find the median of this data. To find the median, we have to find n by 2. Now n in this case is the total frequency, which is 50. So n by 2 is nothing but 50 divided by 2, that is equal to 25. So 25 will be the half of total frequency. Now we'll draw a line from this point 25 and we'll touch the curve, and from that point we will touch the x-axis, and that will be the median. So let's start by forming a line. Now this point on the x-axis is nothing but the median, which is 137.5. So the median of this data is rupees 137.5. Now let's quickly summarize the less than type method. First, identify the upper limits from your data. Second, calculate the cumulative frequencies. Now, mark the upper limits on the x-axis and cumulative frequency on the y-axis of your graph. Then set the scales for your graph and then plot these points onto the graph. Now form a freehand smooth curve. Now this resultant curve would be the less than type ogive. We can also find the median of group data by the formula n by 2. Locate n by 2 and touch the curve and then touch the x-axis. That would be the median of your data. That was all about the less than type method. To learn more, please visit our website www.letstute.com. Keep watching, keep learning, and do subscribe our channel.